So, good evening, all of you. So, I welcome to today's webinar series resource person, Dr. K.S. Lokesh, sir. Welcome to you, sir.
Thank you, sir.
And I also request to welcome to our KST CEO, Chief Executive Officer, Dr. A.M. Ramesh, sir. And I also request our Managing Director of KST and KSTEPS, Dr. A.B. Basaraj, sir, and all attendees. So, I brief introduction about Dr. K.S. Lokesh, sir. Dr. K.S. Lokesh, sir, is presently working as a professor in chemistry at Vijayanagara Sri Krishnadevaraya University, Ballari from 2012. He obtained his master's degree in chemistry and a PhD degree from University of Mysore. Then he worked as postdoctoral fellow at University Joseph Fourier, France from 2008 to 2009, and University of Ghent, Belgium in 2010. Then he worked as assistant professor at Shinshu University, Japan from 2010 to 2012. His research interest includes isoadenals and prochlorine or alkylcyanine based microcycles for electrochemical applications like electrochemical sensing and clean fuel production and energy storage devices. Sir teaches analytical and materials chemistry to master degree students. He has received research funding from DST, CSIR, and VGST of more than 3 crores. He has been awarded India-Uzbekistan Joint Research Project on clean energy production. He has published more than 100 research publications in international journals, 2 books chapter, and 1 Indian patent and 1 world patent to his credit. He has guided 10 students for PhD degree and 7 more are working. He has received awards like Sir C.V. Raman Scientist Award and Best Publication Award from Government of Karnataka. He was awarded TWS Research Fellowship for working in China. He has served at various administrative responsibilities in university like Chairman of Chemistry Department, Dean of Faculty Science, Academic Council, and syndicate member of VSK University, and also a NAC peer review committee member. As part of his research work, he has visited France, Belgium, Italy, USA, Japan, and China. Thank you, sir. About you.
Thank you, Siddhegowda, sir, for elaborative discussion, introduction. I first thank KSPA and Siddhegowda, sir, for inviting me to deliver this lecture. Sir, is it audible?
Yes, sir. Audible, sir. Audible.
Okay. So today, I also welcome all the student participants for this online lecture, and it is my pleasure to deliver the lecture on stoichiometry and stoichiometric calculation. So when I say stoichiometry, it involves the combination, equal combination of different atoms in a molecule. So you have reactant and a product. Both on the reactant side and product side, you need to have mass conservation. That means you need to have same number of atoms on left hand side, that is reactant side, as well as on the right hand side, that is product side. So that we will discuss in today's lecture, and it is the basic of any chemistry reaction and also other reactions related to biochemistry, environmental chemistry, forensic science, or any other types of chemical reactions. So stoichiometry is the basics of any reaction. So in my lecture, I will be covering introduction to stoichiometry and stoichiometric calculations and balancing of chemical reactions the limiting reagent, which is responsible for the formation of the product and the reactions in solution. So I will be covering these topics during my lecture. When we talk about the stoichiometry, the word stoichiometry is derived from two Greek words where stoichion means element and metron means measure. So the stoichiometry means the measure of elements on in a reaction, that is both on the left hand side and the right hand side of the reaction. Stoichiometry deals with the quantitative study of relationship between the various reactants and products involved in a chemical reaction, whether it may be in terms of moles, masses, atoms or molecules, and volumes. That means we need to have the balance on left hand side and right hand side of the reaction between the moles of the reactants and moles of the products formed, masses on the reactant side and the masses on the product side, molecules, number of molecules on the left hand side, that is reactant side, and the product side. Then what are reactants? Reactants are the substances which undergo a chemical change in the reaction. So when you take any reaction, the reactants are the one which undergo a change in chemical reaction, or they undergo some transformation to give a product. They are called as reactant. Products are the new substances that are formed during the reaction. So when a reaction takes place, you normally write the reactants on the left hand side, then with the arrow, that means reaction is taking place. Either it's a forward reaction, if it is a single arrow, if it's a double arrow, then it is a equilibrium reaction or reversible reaction. Then the right side, these left hand side reactants gives some product that is mentioned on the right hand side of a chemical reaction. Therefore, a chemical reaction takes place when the reactants undergo chemical change by reacting with each other to form a required or desired product. So a chemical reaction takes place when the reactants undergo chemical change by reacting with each other to form a desired product. In chemistry, chemical reactions are generally written in the form of equations. We don't write completely as, acid plus base, that is H2SO4 plus sodium hydroxide. But instead of that, we represent the chemicals using symbols. So, for example, instead of writing completely hydrogen, we write H. For oxygen, we use symbol O, sulfur S, and nitrogen N. The reactants, as I said, they are written on the left hand side and products on the right hand side. Then the reactants and the products are separated by a arrow. This arrow, if it is a single arrow, then the reaction is taking place in the forward direction. That is, it is a irreversible reaction where reactants gives rise to a product. Whereas sometimes the reaction between reactants and the products is given by a double arrow, which means the reactants which undergoes reaction to form products, they again undergo degradation or ionization to give initial reactants. So that means this is reversible in nature, reactant to product and product to reactant, when you represent the reaction or the reactants and the products with a double arrow. In the above reaction, hydrogen molecule and oxygen molecule involved in the reaction are called as reactants. So H2 and O2, which are written on the left hand side, they are called as reactants, and the product is written on the right hand side, that is H2O. Water is formed on reacting H2 and oxygen molecule, hydrogen molecule and oxygen molecule reacts to give water as byproduct. It is a irreversible reaction where hydrogen reacts with oxygen to give a water molecule. Water is a product, and the left hand side react substances like hydrogen and oxygen are reactants. The notations which are given in the left hand side or on the right hand side, that is on reactants and the products, G and L, they indicate the phase of the solids or phase of the substance, whether the substance is in solid, liquid or gas. So here G represents the molecules are in gaseous phase. L represents the molecule is in liquid state. Here we have 2H2, the 2 written in front of H2, the 2 written in front of H2, which is called as coefficient 2 in case of hydrogen and 2 in case of water molecule. They are nothing but stoichiometric coefficients. Stoichiometric coefficient 2 written in front of hydrogen molecule, 2 written on the product side in front of water, and even though there is no one, oxygen molecule is having a coefficient of 1 which is not normally written. So 2 for hydrogen, 1 for oxygen and 2 for water written in the chemical reaction, they are called as stoichiometric coefficients. Stoichiometric coefficients, which indicates the number of molecules or moles taking part are formed during the chemical reaction. So the two, one in case of oxygen, two in case of water, they are called as stoichiometric coefficient, and they indicate number of moles or number of molecules of hydrogen and oxygen that are reacting to give the product water. So the basic principle of chemical stoichiometry follows the law of mass conservation, the law of conservation of mass. So when we write stoichiometry, chemical stoichiometry of a reaction, it is involved with law of mass conservation, law of mass conservation or law of conservation of mass. So law of conservation of mass states that in a chemical reaction, when you do a chemical reaction, mass is neither be created nor be destroyed. You cannot destroy any mass or you cannot create any mass during a chemical reaction in which reactants give products. That is, the total mass of the reactant and the product remains equal on reactant side and the product side, or the number of atoms of each element remains same before and after the chemical reaction, thus making a balanced reaction on reactant side and the product side. For example, if you take CH4, which is called as methane, and if you react methane with chlorine molecule Cl2, then it gives carbon tetrachloride, that is CCl4 and HCl. Here, stoichiometric coefficient for methane is 1, stoichiometric coefficient for chlorine is 4, stoichiometric coefficient for carbon tetrachloride is 1, and stoichiometric coefficient for HCl or hydrochloric acid is 4. So when you compare the number of atoms of different elements, number of atoms or atomic mass of different elements on left hand side and right hand side, that is on reactant side and the product side, that should remain same. That is very important in stoichiometric calculations. So here in this reaction between methane and chlorine to give carbon tetrachloride and HCl, The total number of carbon atoms present in the left hand side or reactant side is 1. And the atomic mass of carbon is 12. Since you have only one atom of carbon, the total mass of carbon is 12. And the hydrogen, number of hydrogen present in the reactant side is 4 and its atomic weight is 1. So 4 into 1 is total atomic mass of hydrogen on the reactant side is 4 into 1 is equal to 4. Then we have chlorine. Chlorine on the left hand side or reactant side, there are totally 4 into 2, that is 8 atoms of chlorine. So on the reactant side, and if you calculate the mass of chlorine, it is the atomic weight of chlorine is 35.5. 35.5 into 8 number of atoms of chlorine, which gives you 284. So if you calculate the total number of atoms on the reactant side, it is 13, and the atomic mass, which is given in the units of atomic mass units or AMU, it is 300. The total atomic mass on the reactant side is 300, and total number of atoms on the reactant side is 13. Now, when you have a stoichiometric reaction or chemical balancing of the chemical reaction, then the same number of atoms should be present on the product side, and the products form should have the same atomic mass or molecular mass. So if you take the product side, that is carbon tetrachloride plus 4HCl, the total number of carbon is 1, hydrogen is 4 into 1, that is 4, and chlorine is 4 in chlorine, carbon tetrachloride, you have 4 atoms of chlorine, and in 4HCl, you have 4 atoms of chlorine. Total 4 plus 4, 4 in carbon tetrachloride and 4 in hydrochloric acid. That is, totally we have 8 number of atoms of chlorine. So the total number of atoms on the product side is also 13, and number of atoms on the reactant side is also 13. And if you compare the atomic mass also matches with the atomic mass of the reactants. So the atomic mass on the reactant side is 300, and the atomic mass on the product side is also 300. So the reaction is chemically balanced. The reaction, whatever we are seeing, methane, that is CH4 plus 4 chlorine giving carbon tetrachloride plus 4HCl is a chemically balanced reaction. So how we can balance the chemical reaction? So the balanced chemical reaction is one in which the number of atoms of each element, present on the reactant side is equal to number of atoms of each element on the right hand side or product side. So you should have same number of atoms of each element, on a reactant side and product side should be same. If you take the chemical reaction of calcium carbonate, when you react calcium carbonate with HCl, hydrochloric acid, so you are going to form calcium chloride and carbon dioxide plus water, So calcium carbonate, when you react with hydrochloric acid, it forms calcium chloride plus carbon dioxide plus water. This calcium carbonate is not soluble in water. When you add HCl, what it happens is it gives you effervescence. So the effervescence is due to the release of carbon dioxide, and the reaction will also form calcium chloride and water. The above chemical reaction can be explained as follows. So the different ways of explaining the reaction is 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to give, on the product side, 1 mole of calcium chloride and 1 mole of carbon dioxide plus 1 mole of water molecule. So this is how you can represent the chemical reaction, above chemical reaction, using moles. So we will see what is mole in the next slide. And it can also be, represented as 1 molecule of calcium carbonate, which is solid, reacts with 2 molecules of hydrochloric acid, which is liquid in state, to give the products calcium chloride, 1 molecule of calcium chloride, which is in aqueous or dissolved form, plus carbon dioxide, 1 molecule of carbon dioxide, which is in gaseous state, and 1 molecule of water, which is in liquid state. So you can also represent or inform this reaction in terms of their molecular weights. So the molecular weight of calcium carbonate is 100. So 100 gram of calcium carbonate reacts with 2 HCl. The molecular weight of HCl is 36.5. Since you have 2 molecules of HCl, that is 36.5 into 2 is 73 gram of HCl. To give, the molecular weight of calcium chloride is 111 grams and the molecular weight of carbon dioxide is 44 grams and molecular weight of water is 18 grams. So the above equation can be represented by at least 3 or 4 ways. This is how the above reaction can be written in the word form. So you can represent in terms of moles, you can represent in terms of number of molecules that are reacting, you can represent in terms of the molecular weight of the substance reacting with each other to give the products. So whether you take moles, molecules or molecular weight, it is same on the reactant side and the product side. So how you can do the balancing of the chemical reaction? So the balancing of the chemical reaction can be done if you consider post reaction where you are going to synthesize ammonia from using nitrogen and hydrogen. So this is the reaction is called as Bosch reaction, which is one of the important reaction, Haber-Bosch process for the production of ammonia using nitrogen and hydrogen. Here, nitrogen is reacted with hydrogen to give the product ammonia. Here you are taking 1 mole or 1 molecule of nitrogen and you are reacting with 3 moles or 3 molecules of hydrogen to give a product called as ammonia, which is in terms of 2 moles or 2 molecules of ammonia. Since the nitrogen is a gas, hydrogen is a gas, and ammonia is a gas, you can also convert the 1 mole of substance in gaseous state is equal to 22.4 liters at standard temperature and pressure. So 1 mole of gas, that is, it is either nitrogen or oxygen or hydrogen or ammonia, which are all gaseous molecules. So 1 mole of any substance is equal to 22.4 liters at standard temperature and pressure. That means 22.4 liters of nitrogen is reacted with 3 into 22.4 liters of hydrogen to give 2 into 22.4 liters of ammonia at STP, that is standard temperature and pressure. Or you can also write as 1 ml of nitrogen reacts with 3 ml of hydrogen to give the product with 2 ml of ammonia. So in terms of molecular weight, this reaction, nitrogen, its atomic weight is 14. There are 2 atoms of nitrogen in nitrogen molecule. That is why the molecular weight of nitrogen is 14 into 2, 28 grams. And hydrogen molecular weight is 1 is the atomic weight. There are 2 atoms of hydrogen. It is 1 into 2 is 2. There are 3 molecules of hydrogen reacting with the nitrogen to give ammonia. So 3 into 2 is equal to 6. And ammonia, its molecular weight of ammonia is 17, 14 for nitrogen and 3 for 1 into 3, that is 1 is the atomic weight of hydrogen, and there are 3 hydrogens, 1 into 3, that is 17. There are 2 molecules of ammonia formed. 2 into 17 is equal to 34 grams. From the above example, it clearly indicates that the relationship between the reactants and products of a particular chemical reaction can be studied quantitatively in terms of moles, molecules, mass, and volume. So, above example, whether it is Haber-Bosch process to produce ammonia or the calcium carbonate with hydrochloric acid to give calcium chloride, carbon dioxide plus water, any reaction, it clearly indicates that the relationship between the reactants and the products formed in a chemical reactions are studied quantitatively either using moles or molecules or mass, molecular mass or volume. So we can use any one of the concept, moles, molecules, mass or volume in representing the chemical balanced chemical reaction, that is stoichiometry involved in the reaction. So how to balance the reaction? There are different steps while you do the balancing of the chemical reaction. For example, if you take the reaction between sulfur dioxide and hydrogen sulfide, which gives the product as sulfur and water. So this reaction, in order to balance the number of atoms of different element on the left hand side, reactant side, and the number of atoms of different elements on the product side to be equal, we will rewrite the equations. First thing is, first step for balancing the chemical reaction is we need to rewrite the same reaction. Sulfur dioxide plus H2S gives sulfur plus water. Then in the second step, compare the number of atoms of each element on reactant side and product side of a given equation. So if you compare the number of atoms of different elements, so you have different elements as sulfur, oxygen, hydrogen. There are 3 different elements on the reactant side as well as product side. Sulfur, hydrogen, and oxygen, 3 different elements. And the number of atoms of different elements on the reactant side is sulfur. You have 1 sulfur from sulfur dioxide and 1 sulfur from hydrogen sulfide, that is H2S. So totally you have 2 number of sulfur atoms on the reactant side. In the same way, you have 2 hydrogen atoms in hydrogen sulfide on the reactant side, and there are 2 atoms of oxygen in the sulfur dioxide in the left hand side or reactant side. Now, if you take number of atoms of different elements on the product side, if you see on the right hand side of the reaction, you have only 1 sulfur, S, only 1 S is there. There are 2 hydrogen atoms in water molecule and 1 oxygen atom in water molecule. When you compare number of atoms of different elements on reactant side and the product side, then here it is not equal. Now we need to make sure that number of atoms on left hand side is equal to number of atoms on the right hand side. Third step, choose each element in reactant and product and balance its number of atoms in reactant side and product side. So first we will take the sulfur, or you can take oxygen, anyone you want. So now what we are doing, we are taking the oxygen atoms. So number of oxygen atoms on the reactant side is 2, that is in 2 atoms in sulfur dioxide. And but in the right hand side, you have only one oxygen atom in water molecule. So we need to make sure that the number of oxygen atoms in the left hand side is equal to number of oxygen atoms on the right hand side. So in order to equalize the number of oxygen atoms, we cannot add oxygen to water. If we add one more oxygen instead of H2O, H2O2, then the chemical name or chemical compound becomes different. It's a totally different compound. H2O2 is hydrogen peroxide, which is used as a oxidizing agent and which is slightly toxic in nature, whereas water is a neutral molecule, which is called as biocompatible molecule. So we cannot add oxygen to water on right hand side, as it will change the formula of water molecule. Then the molecule itself, it becomes a different molecule. So for example, if you take sulfur dioxide on the left hand side in the reaction, above reaction, plus H2S gives sulfur plus H2O2, plus sulfur plus H2O2. In this reaction, you can see there are 2 atoms of oxygen on the left hand side, 2 atoms of oxygen on the right hand side. But the chemical formula is hydrogen peroxide, which is a different chemical than that of water. So it is a incorrect product. We need to increase the number of molecules of water, but not change the chemical formula or chemical compound. We cannot change. So how we need to then balance number of oxygen atoms on the left hand side and the right hand side? We can only change the coefficient, that is which is number which is present at the starting of the molecule, at the front of the molecule. So we can only change the coefficient of the complete molecule in order to retain the chemical identity or chemical nature of the given compound or reaction. Thus, the reaction can be rewritten as sulfur dioxide plus H2S gives sulfur plus 2 is now 2, whatever it is in bold, now it is written in front of water molecule. It is called as coefficient or stoichiometric coefficient. Now, if you compare oxygen, so you have retained the chemical identity or chemical formula of water as such. There is no change in the chemical compound. Number of oxygen atoms on the left hand side is 2, and number of oxygen atoms on the right hand side is 2 molecules of water, that is 2 into 1 oxygen, 2 oxygen. That means equal number of oxygen atoms on the reactant side as well as product side. So now we have balanced the equation only with respect to oxygen. Now we will go to the balancing of other elements. So next step in the balancing of the reaction on the reactant side and the product side. Now oxygen is over. Now we will go for sulfur. So next, hydrogen atoms. So if you take from the oxygen balanced equation, oxygen atoms balanced equation, that is sulfur dioxide plus H2S gives sulfur plus 2 water. So here, how many hydrogens are there? On the reactant side, we have 2 hydrogen, but on the product side, we have 4 hydrogen atoms, 2 into H2, 4 hydrogen. So in order to balance the equation for hydrogen atoms in the equation, we need to multiply 2 as coefficient for hydrogen sulfide, so that you will have same number of atoms of hydrogen on the reactant side as well as the product side. So in the balanced equation, sulfur dioxide plus 2H2S gives sulfur plus 2H2O. You have 4 number of hydrogens on the reactant side and 4 number of hydrogen atoms on the product side. Now we have done balancing of oxygen atom and hydrogen atom. The remaining one is sulfur. So next we will take the reaction which is used for balancing hydrogen atoms. The balanced equation is sulfur dioxide plus 2H2S gives sulfur plus 2H2O. So now we need to balance number of sulfur atoms on the reactant side with the number of sulfur atoms on the product side. So on the reactant side, we have one sulfur from sulfur dioxide and two sulfur from hydrogen sulfide. Totally, there are 3 sulfur atoms on the reactant side. So in the product side, we need to introduce 3 at sulfur. That means 3 moles, 3 atoms of sulfur is is formed during the reaction between sulfur dioxide and hydrogen sulfide. So now the overall balanced equation is can be written as sulfur dioxide plus 2H2S gives 3 sulfur plus 2 water molecule. So here the different elements present on the left hand side and right hand side of the chemical reaction is sulfur, hydrogen and oxygen. In this balanced equation, the last equation that we have, the number of sulfur atoms is 3 on the left hand side and the number of sulfur atoms on the product side is also 3. The number of hydrogen atoms on the reactant side is 4 and the number of hydrogen atoms on the product side, that is 2H2O, 2 into 2, 4 atoms of hydrogen. That is same number on the reactant side and the product side. And if you take oxygen, so oxygen, same thing. So there are 2 oxygen atoms in sulfur dioxide on the reactant side and there are 2 atoms in 2H2O in the product side. That means here the number of atoms of different elements on the left hand side are matching with the number of elements of different elements on the right hand side. Now the reaction is called as balanced equation or balanced reaction. So left hand side, right hand side, there are same number of atoms, same number of molecules, same number of molecular mass. So you can see in this balance, you have same number. You have same number on the left hand side and the right hand side. So where we can use this stoichiometry or how you can represent using solution. So the quantitative information obtained by a chemical equation helps in calculating different problems. So especially in NEET and CET, you don't have direct questions, but instead you will have, how you can calculate different aspects or parameters from these stoichiometric relationships. So you have mass relationships. So the mass relationship gives you information about mass of one of the reactant or product is given and mass of other reactants or products needs to be calculated. So in the NEET or CET exams, what they will do, they will give you either the mass of either the product or the reactant. You need to calculate either the mass of reactant or product. One is given and the other one is you need to calculate. You need to have either mass volume relationship. So what they will do, the mass or volume of one of the reactants or products is given and you need to calculate the mass or volume of others. So one is given, mass or volume of the reactants is given. You need to calculate mass or volume of the product. So in the earlier case, it is only mass. Now it is mass to volume relationship. The third one is volume to volume relationship. The volume of one of the reactants or products is given. So volume of one of the reactants or product is given. You need to calculate the vice versa. The other one which is not given, you need to calculate using this stoichiometric relationship or balancing of the chemical reactions. So when you have mass relationship, how to find the mass? Either when you have been given the mass of the reactant or mass of the product. So one example is, find the mass of carbon dioxide gas produced when 4 gram of methane is burnt in presence of is combusted or burnt in the presence of excess of air. So you need to find what is the amount of air produced or carbon dioxide produced when you burn 4 gram of methane. So first thing is write the reaction, then balance the reaction. Then using the balanced reaction, you need to find what is the amount of carbon dioxide gas formed when 4 gram of methane is combusted or burnt in excess of air. So the balanced chemical equation for this reaction is oxygen is combusted in excess air, means in presence of oxygen, and methane formula is CH4. So CH4 when reacts with or combusted in presence of excess air, that is oxygen, gives carbon dioxide plus water. Here the number of moles on the left hand side or reactant side should match with number of moles on the product side. Here you have 2 moles of oxygen and 1 mole of methane. 1 mole of methane. So it gives 1 mole of carbon dioxide and 2 moles of water. If you compare number of atoms on the left hand side for different elements with number of atoms for different elements on the right hand side, they are equal. With respect to oxygen, carbon and hydrogen, you have same number of atoms on the left hand side and the right hand side. So mole ratio is equal to given data, what is the given data and what is the asked or what we need to find. So methane, when you burn methane in excess air, it gives carbon dioxide. That means from the balanced equation above, you can find 1 mole of 1 mole of methane reacts with oxygen to give 1 mole of carbon dioxide. So you need to find what is the amount of carbon dioxide formed when 4 gram of methane is burnt. So methane molecular formula is CH4 and its molecular weight is 16 grams. 16 grams is the molecular weight of methane, and 1 mole of methane is equal to 1 mole of carbon dioxide. That is, carbon dioxide molecular weight is 44 grams. 16 into 2, that is oxygen atomic weight is 16. There are 2 atoms of oxygen plus atomic weight of carbon 12. Total is 12 plus 32, which is equal to 44. So you have for each mole of methane 1 mole of carbon dioxide. That is molecular weight of methane or moles of methane. 1 mole of methane is nothing but molecular weight of methane, that is 16 grams, equal to 1 mole of carbon dioxide, which is equal to 44 grams of carbon dioxide. Thus, how much of carbon dioxide released for 4 grams of methane? So if you do cross multiplication, that is 44 divided by 4, into 16, or so for 16 it is 44. For 4 grams, how much? Then you will get 11 grams of carbon dioxide. 11 grams of carbon dioxide is produced when you heat or burn or combust 4 grams of methane. 4 grams of methane. Therefore, 4 gram of methane produces 11 gram of carbon dioxide. Then you have now earlier case mass relationship. In this we will see mass volume relationship. Mass volume relationship. So in this what they have asked, the question is find the volume of carbon dioxide produced on, find the volume. Now it's not the mass. Earlier case what is the mass they were asked. Now they are asking what is the volume of carbon dioxide formed when you are heating, how much amount of carbon dioxide methane. So when you are heating, so some amount, that is 32 gram of methane in presence of excess air. So you need to find what is the volume of carbon dioxide produced when you heat 32 gram of methane. So you need to find the volume of carbon dioxide. The balanced equation is same like earlier case. Two molecules of oxygen reacts with methane to produce carbon dioxide molecule and water molecule. So number of moles on left hand side and right hand side is 1 mole of methane reacts to give 1 mole of carbon dioxide. So 1 mole, for if you burn 1 mole of methane, it will give 1 mole of carbon dioxide. Now you need to find what is the volume of carbon dioxide produced when you burn or when you combust 32 gram of methane in excess air. So you have 16 gram of methane. 1 mole of methane means 16 gram of methane, which is equal to molecular weight of methane, is equal to 44 gram of carbon dioxide. That is 1 mole of carbon dioxide is nothing but 44 gram of carbon dioxide, which is again equivalent to molecular weight of carbon dioxide. Now you need to find what is the amount of carbon dioxide released when 32 gram of methane is burnt. So 40 into 2, 44, 16 into 2 is 32. So you need to do on the right hand side also, so that you have the balancing of left hand side and the right hand side. 44 into 2 is equal to 88 gram of carbon dioxide. 88 gram of carbon dioxide. So 1 mole of carbon dioxide is nothing but, that is 44 gram of carbon dioxide, or 1 mole of carbon dioxide is nothing but 22.4 liters of carbon dioxide at standard temperature and pressure. So you have 2 moles of carbon dioxide produced. So 2 into 22.4 liters is equal to 44.8 liters of carbon dioxide is produced on burning 32 grams of methane in excess air. So we have found volume of carbon dioxide released when you burn 32 gram of methane. So you have converted mass volume relationship. They say mass is 32 gram of methane, volume is nothing but 44.8 liters of carbon dioxide produced. Mass to volume relationship, mass to volume relationship. Then we will go to another formula, volume to volume relationship. So first one is mass to mass, the second one is mass to volume. Now volume to volume relationship using stoichiometric relationship. How to calculate volume? If volume of reactant is given or volume of product is given, how to calculate the volume of the vice versa? That is done in this problem. What volume of oxygen at standard temperature and pressure is required to burn uh, ethane gas, to burn the ethane gas. So the balanced chemical equation is ethane. The formula is C2H4, C2H4. And when it is burnt with oxygen or excess air, it gives you carbon dioxide plus water. Carbon dioxide plus water. Here, when you do the balancing of the reaction on the left hand side and the right hand side, then 1 mole of ethane produces 2 moles of carbon dioxide. 1 mole of ethane produces 2 moles of carbon dioxide. So then what you have to do, what is the amount of carbon dioxide produced or oxygen required if you have burning of, if you are supposed to burn 500 dm cube of ethane, 500 dm cube of ethane. So you have, based on this equation, 1 mole of ethane requires 3 moles of oxygen to give 2 moles of carbon dioxide. Now, as per their question, we need to find what is the amount of or volume of oxygen required to burn completely 500 dm cube of ethane, 500 dm cube of ethane. So, for 500 dm cube of ethane, we need 3 into 1 mole of ethane is equal to basically 3 moles of oxygen. So 1 mole of ethane is equal to 3 moles of oxygen. Ethane is nothing but 24 plus 4, 28. 28 is the molecular weight of ethane and 32 is the molecular weight of oxygen. But here the volume of ethane is given in dm cube volume. So what we are doing, we are comparing just the number of moles or molecules on the ethane and number of molecules on the oxygen. So for 500 dm cube of ethane, you need to multiply 3 times the oxygen, 3 times the volume of ethane, 3 into 500 dm cube. So is equal to 1500 dm cube of oxygen is required to burn 500 dm cube of ethane. 500 dm cube of ethane requires 1500 dm cube of oxygen at standard temperature and pressure. So then next we'll go to the last topic. So where we'll have something called as limiting reagent. Limiting reagent. So in any chemical reactions, we will have two types of reagents. So one is called as limiting reagent. So the other reagent is called as excess reagent. So the reagent which is present in lesser quantity and which consumes completely during the reaction progress, during the formation of the product, it is called as limiting reagent. So limiting reagent is the one which is present in lesser quantity and which gets completely consumed during the reaction progress to form the product is called as limiting reagent. So the reagent which exists in larger quantity, that is called as, excessive reagent. The major difference between the limiting reagent and the excess reagent are as follows. So the limiting reagent limits the formation of products. That means the number of or the moles of weight of product formed is based on the amount of limiting reagent present in the reaction. So it limits the formation of product, that is the amount of product formed is completely dependent on the amount of limiting reagent. Then what is excess reagent? It is present in excess quantity than required by the reaction to form product, that is called as excess reagent. So limiting reagent it is completely consumed during the reaction, whereas excess reagent do not completely gets consumed during the reaction. So limiting reagent, it will not present. It is, since it is completely consumed during the reaction, there is no trace or small, even small amount of limiting reagent is not present after the completion of reaction. Whereas in case of excess reagent, some excess reagent is left over even after the completion and the other one is excessive reagent. So one problem we will do with the respect to that, and we will finish it off. The limiting reagent calculation. So the amount of limiting reagent can be measured using the following relationship. So limiting reagent is equal to given value, whether it is in moles, volume, or molecules. So when you do the balancing of the reaction, normally you can do with respect to moles, volume, or molecules. So divided by limiting reagent is equal to given value in terms of moles, volume, or molecules divided by stoichiometric coefficient. Stoichiometric coefficient. So when you have a reaction in which A is a reagent which reacts with 2 molecules or 2 moles of B reagent, so giving a product C and 2D. So here A is involved with respect to formation of the product. A used is 3 moles and B used is 9 moles, and C and 2D are 3 moles and 6 moles. So here 3 minus 3, that is whatever the limiting reagent with lesser concentration or lesser amount you have taken, that is A, that same amount of product C has formed. 3 minus 3 is 0. 3 moles of A reacted with 3 to give 3 moles of product C. So 3 minus 3 is equal to 0 mole. That means all the limiting reagent has reacted with another reagent, excessive reagent B, to give product C. There is no reagent of A left over after the completion of the reaction. All the limiting reagent, that is A, has been reacted during the reaction between A and B to give product C. Therefore, limiting reagent A is equal to 3 by 1. 3 by 1 is equal to 3. Limiting reagent of B is equal to 9 moles divided by 2 molecules. 2 molecules is equal to 4.5. So for limiting reagent of A is 3, ratio is 3. Limiting reagent of B molecule or B reagent is 4.5. So if you compare the ratio of limiting reagent A to limiting reagent B, 3 is greater than 4.6. 3 is less than 4.5. So which is having lesser amount, that is taken as limiting reagent. In this case, A reagent is having lesser amount. That is why the reagent A is taken as limiting reagent. A is taken as limiting reagent. So this is about today's topic, stoichiometry. And sometimes what we do when we have solutions, so solutions we don't say in terms of mass normally, or moles, or atoms. Normally the concentration of the solution, when you dissolve a compound in a suitable solvent, then we represent the concentration of the solution. in terms of either mass percent or weight percent or mole fraction, molarity and molality. These are the different ways of representing strength of a solution or concentration of a solution, or strength of the solution. So since we carry out many of the reactions in suitable solvents or as solution, so it is always better to find the or represent the concentration of the solute in solution or solvent using one of these parameters or one of these strengths, that is either as mass percent, mole fraction, molarity or molality. So what is mass percent? It is the ratio of mass of the solute of a element or a solute or element to the total mass of the solution. The obtained result is multiplied by 100 to give percentage. So mass percent is equal to mass of solute divided by mass of solution into 100, which is represented as mass percent. So mass of solution is nothing but mass of solute plus mass of solvent. That is called as mass of solution. In solution, normally you are dissolving the solute in a solvent to form solution. So mass of solution is nothing but mass of solute dissolved in a known mass of solvent. So then mole fraction. Mole fraction is also used to represent the concentration of a solution. So mole fraction is given by number of moles of solute divided by total number of moles of solution. So X solute or mole fraction of solute is equal to number of moles of solute divided by total number of moles of solution. Total number of moles of solution is nothing but mole fraction or moles of solute plus moles of solvent. So solute mole fraction is given by number of moles of solute divided by number of moles of solute plus number of moles of solvent. Then we'll go to molarity. So molarity is defined as the number of number of moles. So mole is equal to the molecular weight of the substance. Number of moles of solute present in 1 liter of the solution. So molarity is another way of representing the concentration or strength of a solution, which is normally used in carrying out a reaction. So molarity is given by the number of moles of solute present in 1 liter of solution, and molality is given by the number of moles of solute present in, instead of 1 liter, it is 1 kg of solvent. In the previous case, in the molarity, it is number of moles of solute present in 1 liter of solution, 1 liter. Here, instead of 1 liter molality, it is instead of 1 liter of solution, 1 kg of solvent. Number of moles of solute present in 1 kg of solvent. That is called as molality of the solution. So then we have what we have discussed today is the stoichiometry. What is stoichiometry? Then we came across balancing of the chemical reaction. What are the steps we need to use during the balancing of the chemical reaction? Then what is limiting reagent? Then with respect to calculation of some parameters like mass to mass relationship, mass to volume relationship, and volume to volume relationship, how we can find the either the product form or reactant used, then we know one of them. Then we also gone through the different strengths, the way of representing the concentration, that is mass fraction or mass percent, mole fraction, molarity, and molality of the solution. Now, I request the students, if they have any questions, they can, interact with me, or they can ask questions. Siddhegowda sir.
ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಏನಾದರೂ ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಇವಾಗ ನೀವು ನೇರವಾಗಿ ಈಗ ಸರ್ ಇದ್ದಾರೆ ಕೇಳಬಹುದು. ಇವತ್ತಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದ ಟಾಪಿಕ್ ಆದಂತಹ ಸ್ಟಾಕ್ಯೋಮೆಟ್ರಿ, ಇದ್ರ ಮೇಲೆ ನಿಮ್ಗೆ ಏನೇ ಡೌಟ್ಸ್ ಇದ್ರು ಕ್ವಶನ್ಸ್ ಕೇಳಬಹುದು. ಯಾವುದೇ ಡೌಟ್ಸ್ ಇದ್ರೆ ನೀವು ಇಲ್ಲೇ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೋಬಹುದು. ಪ್ಲೀಸ್ ಕಾಸ್ ಎನಿ ಕ್ವಶನ್ಸ್.
You can send me a mail if you have any questions related to this topic.
Yes, sir. If they send the questions, I send through mail, sir.
Yes.
So anyway, today is a very informative talk on stoichiometry, sir. I thankful to you, sir.
Thank you, sir.
Myself also, sir.
It's my pleasure to interact with the students, sir.
Yes, sir. ನೀವು ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ನೀವು ಸರಳವಾಗಿ ಸ್ಟಾಕ್ಯೋಮೆಟ್ರಿ ಅಂದ್ರೆ ಏನೋ, ಅದು ಯಾವ ಸ್ಟೆಪ್ಸ್ ನ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ, ಅದನ್ನ ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಂತ ಒಂದು ಸುಮಾರು ಸಮಗ್ರ ವಿಚಾರಗಳನ್ನ ಬಾರಿ ಸರಳವಾಗಿ ಮಕ್ಕಳುಗಳಿಗೆ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದಾರೆ ಸರ್. ಸೊ ಮತ್ತೊಮ್ಮೆ ತಮಗೂ ಧನ್ಯವಾದಗಳು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು.
ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜಿಸಿ ನಮಗೆ ದಿನನಿತ್ಯ ಸಲಹೆ ಸೂಚನೆಗಳು ನೀಡುತ್ತಾ ಬಂದಿರುವ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂಥ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಸೊ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ನಿರ್ದೇಶಕರಾದಂಥ ಎ ವಿ ಬಸವರಾಜರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಸೊ ಇಂದಿನ ದಿನದಲ್ಲಿ ಹಾಜರಾಗಿದ್ದ ನನ್ನೆಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. ಸೊ ನಾಳಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಬಸವ ಕಿರಣ್ ರವರು ಉಪನ್ಯಾಸ ನಡೆಯಿತು. ಇಂದಿನಂತೆ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಜರಾಗಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ. ಹಾಗೂ ಆಕ್ಚುಲಿ ನಾವು ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ 320 ವಿದ್ಯಾರ್ಥಿಗಳು. ತಾವು ಹಾಜರಾಗ್ತಾ ಇರ್ತಕ್ಕಂಥ ವಿದ್ಯಾರ್ಥಿಗಳ ಸಂಖ್ಯೆ ಭಾರಿ ಕಡಿಮೆ ಇದೆ. 60-70 ಜನ ಮಾತ್ರ ಆಗ್ತಾ ಇದ್ದೀರಾ. ಸೊ ಇನ್ನು ಉಳಿದವರು ಕಂಟಿನ್ಯೂಸ್ ಯಾರು ಹಾಜರಾಗಲ್ವೋ ಅಂತವ್ರಿಗೆ ತಮ್ಮ ಮಾಸಿಕ ಸ್ಕಾಲರ್ಶಿಪ್ ನ ತಡೆ ಹಿಡಿಯುತ್ತಾರೆ ಅಂತ ಈಗ ನಮ್ಮ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ಮತ್ತೊಮ್ಮೆ ತಿಳಿಸ್ತಾರೆ, ನಾನು ತಿಳಿಸ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಹಾಗಾಗಬಾರ್ದು. ತಾವೆಲ್ಲರೂ ಸ್ಕಾಲರ್ಶಿಪ್ ನ ಪಡ್ಕೊಂಡು ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿ ತಮಗೆ CET, JEE ಮತ್ತು NEET ಪರೀಕ್ಷೆಗಳಿಗೆ ಯಾವ ರೀತಿ ಪ್ರಿಪೇರ್ ಆಗ್ಬೋದು, ಮತ್ತೆ ಉಪನ್ಯಾಸಕರು ನೀಡತಕ್ಕಂತ ಆ ಒಂದು ವಿಷಯದ ಮೇಲೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ನಮಗೆ ಬರ್ಬೋದು ಅನ್ನೋದನ್ನ ಅವರು ದಿನನಿತ್ಯ ಪ್ರತಿಯೊಂದು ಟಾಪಿಕ್ ಮೇಲೂ ಕೂಡ ನಮ್ಮ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ಸ್ ಗಳು ಹೇಳ್ತಾ ಇರ್ತಾರೆ. ತಾವು ದಯವಿಟ್ಟು ಹಾಜರಾಗಿ ಈ ಎಲ್ಲಾ ಕಾರ್ಯಕ್ರಮದ ಉಪನ್ಯಾಸಗಳನ್ನು ಕೇಳಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ತಿಳಿಸಿದ್ದೇವೆ. ಥ್ಯಾಂಕ್ ಯು ಅಂಡ್ ಆಲ್ ಯು. ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಒನ್ಸ್ ಅಗೇನ್.
Thank you, sir.
ಓಕೆ ಸರ್.